Seems like it's been a while to do a what's inside, but here's something I'm actually kind of excited about for some of its parts. So this is I'm not exactly sure, I just got this for free from a friend and I get to play with it. It looks like on the front it's a Krups and, well, it smells like beer, so that's probably what it does. And it's just coated and it's ugly and I'm hoping I don't get too much beer everywhere. I already took out the can it had in it, but it has this little canister that I'm assuming has beer. Looks like there's a little hose in here that runs to what I'm assuming would be a tap right here. And then on the other end there's a little nozzle which might have something like an air compressor or something that pushes it out. That would be my guess. I don't really want to play with the beer because I'm afraid if I do I'm going to end up with beer everywhere, which is not optimal. I don't want my room to smell like beer. The really interesting thing sold me was this. There's a big heatsink on here with a fan, and because it's chilled, that almost always means there's a Peltier unit. Peltier units have been used for quite a few smaller devices like this, and the advantages are it's one solid state device, unlike a air conditioning unit, which has like a hot side and a cold side and a fluid that gets pumped around. It does a lot better at very low powers, so this is probably sub 100 watts. I might measure it though. And it's really cheap compared to a full-on air conditioner, and I think there's a lot less like environmental regulations too, because normally the stuff that goes into air conditioners and AC units is quite toxic or somehow just not great. So that's my most interesting part. Before I start taking it apart, I'm just curious how it'll turn on and what it does. I see this little light, I think, on the front here, and on the back there's nothing, so it doesn't look like there's too many controls, which would either mean it's regulated by temperature or just always runs it. We'll find out how much power it uses though, and if it even works. So, I've just fired it up, and my kilowatt meter says it's pulling about 65 watts. Another thing to see how much they cheaped out on is power factor. Yep, they're using a cheap power supply because the power factor is awful. And I can hear the fan from here, so it's not particularly quiet. It's moving a reasonable amount of air. Looks like it sucks it in from the bottom and blows it out the side. And you know what would be fun? Let's pull out the thermal camera and see if there's anything exciting and see what it looks like temperature-wise after running it for a couple minutes. So I've left it running for a little bit. The power's dropped to 40 watts, which seems about right because as time goes on, the power consumption of these go down as the temperature difference greatens, I think. Looking at it through the thermal camera, we can see it's definitely producing heat on the bottom, on the heatsink fins here. And now let's pop this lid. And if we pop this lid in here, we can see it's definitely cold. It says -6 Celsius, which kind of feels right, but I can't tell by hand. Probably emissivity is wrong, so I'm not going to trust those numbers, and it's definitely hot. So it's a working Peltier unit. Let's go take it apart and see how exactly it works in here. Another thing I missed is the light on the front seems to start at red and then turns green once it gets cool enough. But now on to the taking apart part of the video. So it looks like this bottom is a separate piece of plastic, but I'm not entirely sure how it comes off. There's 2 screws at the back, and it looks like it kind of slides backwards. So I'm going to give that a shot. It's weird how the fan is still spinning. That's very interesting, because I wouldn't expect that fan to be spinning for so long, because it's been unplugged for a reasonable amount of time. Maybe there's a battery? That would be very interesting. Or it could be running off the thermal difference. That would be even weirder. Because with these Peltier units, they can also run in reverse. So if you put power in them, they make a temperature difference. If you give them a temperature difference, they make power. Now you may think, wow, that's a great way to generate energy. And the answer is it makes very little energy in almost all use cases. So it's almost practically useless unless you're trying to power a very small microprocessor or something. Okay, time to get a little bit more brutal now that it doesn't want to just pop open. We're going to make it open. So there's a screw I could get bolt by pulling out this thing and then pop off a few tabs. And now this is out. So this looks like a temperature sensor cable if I had to make a guess. And then there's what feels like a hose here. If I'm right, that hose might be doing the pressure. But we'll find out how exactly it's doing that. The other question is now getting the rest of it apart. I was guessing the bottom came off somewhat easily, but now I'm beginning to doubt that. Maybe this piece just has to pry off, but I'm not... Ooh, that's not the sound I like to hear. So now we got the first part of the bottom off. We can see here's the fan I was talking about and showing. This looks like your power supply in here. One nice way is it looks cheap, but I can't tell that well from just this viewpoint. I'm right, this really looks like a pump. We have a little motor here. I'm curious what triggers that, because I didn't hear that turning on. And also, it seems to be pretty well isolated, because there's quite a bit of rubber here. Interesting, they put a lot of work into isolating this, but the fan's pretty loud. I don't know, I guess the fan is also isolated, but weirdly enough, the cable's zip-tied to it. I'm not sure. Another interesting thing is I've noticed the heatsink fins, when feeling them, have gotten all cold again. And something tells me the way the insulation works is there's actually quite a significant thermal mass on one side. So once it starts to cool down, and that might explain the fan thing. That'll be fun to play with to see if I can actually generate enough power using this to spin the fan. Because from everything I've seen before, Peltier units are extremely bad generators. Which makes them not practical to use for things like, you know, if you had like a water-cooled PC, use a Peltier unit to save a bit of power. Another thing, looking from the construction of this, it's not really designed to be taken apart or repaired, which is unfortunate. And looks like there seems to be a good chunk of glue in some places holding it together, so this thing's never coming together again, but I don't need it to be. But I kind of want to just seal out the inside of the cooler. I think it said some sticker on the bottom about insulation. Here's a look at the dispensing mechanism. If you move this, it moves this little thing in here. Surprisingly heavy, probably just to make it feel more substantial. And then that just, what it seems to do is move this little clip right here, which opens and closes the valve. So I'm starting to take apart the pump system. So this is the hose that goes into the back of it. There's this little circuit board here, which appears to be some sort of, I'm guessing, pressure meter. And that's probably how it determines if it should pump or not. There's quite a few pins on here, and there's a little DIP 6 looking package, which seems like quite a bit for just a pressure system, but it might also be doing something like flow as well. I'm not entirely sure, and I can't really see any markings on that chip. And then right here is the actual pump unit itself. I want to get the Peltier unit and the power supply out, but both of those seem like quite an annoyance. And from the looks of a lot of these plastic body pieces, they're being held in by the insulation. So there's no easy way to pull them, because like if I pull them, I notice I kind of hear the peeling sound of the insulation, which there was a big warning about it. Can insulation blowing glass? I don't know. So I do want to open it up still and see if I can get at it. It's just like this whole side thing's one piece, so if I want to get this piece off. I've gotten some more stuff off with the Peltier unit, and I've gotten the pump fully detached. It looks like some just no-name Chinese fan from what I can tell. Or at least I don't recognize it. And just more plastic bits. From the looks of it, I can start to see the insulation in some places. So that's telling me that I am right about the whole insulation thing. So if I look like right where the pump was, I see kind of this like white kind of squishy stuff, and I can poke out the screwdriver. So they probably use some sort of spray-in insulation, which is probably reasonably effective at being insulation, but is very annoying to work with in this situation. You can see here's the Peltier unit, which I'm definitely going to go and try to pull out. Those are very fun to play with for projects. A little bit more plastic, and here's the power supply. I am not an expert in power supply design, but I will say that this looks like it's not the highest of quality, just from not using a full-on bridge rectifier, the fact they had no power factor correction, then again it's pretty low wattage. I'm just tempted to say it's not the highest quality of units. Probably also it doesn't really matter, because things like Peltier units aren't very picky about power compared to some other devices. I'm going to go try to pull this guy out now and see if I can get under it, and hopefully that'll make it easier to take out the Peltier unit. So here's the power supply has been pulled out now, which also the power supply has the little bit of controller logic on it with the microcontroller. I'll take a closer look at that in a little bit. We can see there's a lot of cables going to the back here, which was where the pump and the pressure meter was. A biggish cable going here. A lot of these looks like just interconnects here. I'm not exactly sure why they put those in the middle. Maybe those thermal cutoffs too. Two large cables. I'm curious why they have two. And also, going under here is another unknown device with a little vent. a little just kind of plastic cover of screws. So we're going to pop that open and see what's hiding under there that goes into the power supply. So that's very interesting. That covers just another piece of foam with the cable going to it that goes to the other side, it looks like. And plugs into the, that cable actually plugs into this guy. And it goes under here. So that'll be interesting. Next thing is taking out the Peltier unit, which there's nuts that looks like you can't access it, and 2 Phillips screws. I am going to just assume the Phillips screws hold the heatsink on, and hopefully I'm right, and the nuts hold on the Peltier unit. There's some power connectors going under it. This is almost certainly 12 volts. Most of the ones I see in these units are. And we'll be able to just power it with any 12 volt power supply and start cooling stuff. Now, one thing everyone pulls up is, oh, can you cool a computer with it? And the answer is, yeah, I mean, it cools, but if you put a high-power chip behind it, it's not going to do anything useful. It'll actually probably be worse because it's not a very good thermal insulator. So you're probably going to want liquid cooling and a lot of these units to do it. And at which point you're burning so much power, you might as well just use a traditional air conditioner style unit, which has, like, you know, compressor and everything, which, yeah, if you don't want to go really overkill cooling, you can. But I haven't seen Peltier units practically used in desktops before. I've tried them quite a bit. I did an earlier video with one, and everyone complains, oh, you're going to get condensation. And it's like, yeah, technically it is, but if you look at the temperatures, the moment you're not idle on a CPU with these things, everything's well over ambient. Here's our units itself, so it's covered in insulation as one may expect, with the actual unit kind of being buried in it. So I think that little layer right there, it's going to be pretty hard to see on video, but there's a little layer sandwiched in between a big heap of metal and there. And I'm just going to leave this rubber on it actually for a little bit right now, and that's what does it. Well, I'm going to go fire this up in a little bit and we can see. And it looks like the other thing was there's this little switch in here. I'm assuming that's a thermal cutoff, just to make sure that if something goes wrong and it gets too hot, probably mostly for fan failure, so the whole system can't go kaboom. And then there's this connector going to it, and that's that unit. Now let's look inside and see what other weird things we can pull out of here. So once we pull out the rest of the screws, you can get the pump. It's surprisingly still cold. It seems to be a reasonably good insulator. I think it's going to struggle to cool a whole thing like a 2-liter equivalent bottle of beer, because that's a lot of thermal mass you have to cool, because it's mostly water in beer, and that's a lot. Yep, it'll probably take a while, and it'll be very inefficient doing so. So here we noticed we have the little pump unit. So here's the air output. I'm guessing this little hose on the other side is the input. Let's go take the top off this and see how this pump works, because there's a few ways you can do small pumps like these, depending on your needs of pressure and flow. Here we go. Here's the diaphragm. So if I was to run this pump, which unfortunately I can't, but this would move up and down like a little piston. It'll be sealed in here. And what happens is these there's 2 little valves in here, and they will only let it in through one way. So it goes in one, out the other. It's a little diaphragm pump. It should work with basically any fluid, which is the advantage of these. Now this is a small one, but the big ones you can pump pretty nasty stuff through. And it has reasonably high pressure, which is probably what they wanted, because if you want to put air into a bottle so you can pump the liquid out, you need a relatively substantial amount of pressure. But that was the little pump. Now let's take a look at the power supply. So this is the power supply, but also the controller board, and it does everything, it seems like. So AC goes in here. It looks like they made different versions for different countries from the check mark. So this is the US model, 120 volt, 60 hertz. Power goes in through here. Basic filtering, bridge rectifier in here. No power factor correction because it's cheap and low power. That's the main switcher IC. Goes into the transformer, and then it comes out. These 2 little diodes filter it. Actually, that might be a big diode there. And then we see a couple of outputs for the different devices, which probably are switched by, yep, there's a relatively beefy transistor here. And then there's a little IC here, which I'm guessing does everything. They kind of surprised me. I was first a bit lost looking at this board, but then I realized This is an LM324, which is a quad op amp. Which the surprising part for me is they don't have any what looks like microcontrollers on here. So it's somehow doing this all with op amps. They must have some sort of, I'm guessing that's what this trimmer pot is here for. And it basically says if the voltage goes over the threshold set for that temperature probe that was stuck in the back, it'll switch the light and turn off the thingy. And there might be another cutoff that turns off the TEC so it can save power when it's not needed. But also those kind of just only get so cold, so they might as well almost just keep it running. From the looks of the way they wired this TEC connector or the Peltier unit, it's always running. So there you go. Yeah, that was surprising. I thought they would have just done a microcontroller, because that's what almost everyone else seems to be doing these days. That was a pretty fun look for me in here. I don't think I'm going to bust the rest of this open, because to my knowledge, this is pretty much just all foam in here. And I don't really like cutting away at insulation, because at least to me, there's nothing fun in here. I can do more future videos of other parts of this if you'd like, or just kind of play around with them, try to cool random stuff with that Peltier unit. The power supply should just be a 12-volt power supply, which might be useful. The pump might be fun for little pumping projects. I mean, you could technically use it in like a computer water cooling setup, but the issue is I'm guessing it's pretty loud and has a lot of vibrations from the amount of rubber they're using. And also it's very low flow and high pressure, which you don't really need in a water cooling system. Normally those are built a lot more on the idea of low flow, high flow, low pressure. So thanks for watching this teardown. Let me know if you want to see anything else or do anything with these parts, and subscribe for more videos like this in the future.